factoring polynomials by the GCF, we have to keep a couple of things in mind. When we're factoring by the GCF that we find actually becomes one of the factors. So the GCF is one of our factors in our answer. And then after we're actually going to do dividing, and the result, and just like we did yesterday, we're going to divide, but the resulting terms after that dividing by the GCF becomes the other factor. So the resulting terms after dividing by each of them by the GCF. We did that dividing yesterday, but then we just left those results that we had, we just left them alone. We only had to identify the GCF. Today we're actually going to use those. So let's just start practicing here. Factor each polynomial. We have, what kind of a polynomial is that? 5b plus 9b cubed. What kind of a polynomial is that? What would you call that? Cameron? A binomial. Okay. In fact, what degree is it?
Third.
Okay. For Josh, thank you for raising your hand.
Oh, right now it's 1.
It's a 1-degree polynomial? It's a 3rd-degree polynomial, it's just not in standard form, right? Okay, so it's a 3rd-degree binomial is what it is right now. Okay, we're going to factor it, and when we're done factoring it, we should have 2 factors. One of our factors is going to be the GCF, the other factor is going to be the result that we would get after we do the dividing. So we're going to do the same, we're going to start the same way we did yesterday. The GCF of 5 and 9. What is the GCF of 5 and 9? Except this time, we're not going to necessarily show 5 and then 9 and dividing by. What do you think? 1. There is nothing else that goes into 5 that also goes into 9 other than 1. So the GCF of the number parts is 1. How about the GCF of the variable parts?
B to the just B.
Just B, yeah. This has 1 factor of B. This one has 3 factors of B. We got to be able to take the same amount out of both of them. So we can only take a B out of both of those. So we have to say our GCF of the variable parts is B. So remember, what do we do with those? We multiply them. So 1 times B is 1B. Or we'll just call it B. How about? The GCF is B. Cleaned up. Okay, so that's going to be important that we first of all come up with a good GCF. Now we're going to do like we did yesterday. We're going to, we were doing some dividing, but now we're going to be dividing by the actual GCF combined rather than separate. So we're going to divide both of those by our GCF, both of the terms of our polynomial. Our polynomial has a term of 5b, and it has a 9b cubed term. Let's put a plus sign right here to show that that's really our polynomial right there that we're working with. Let's just put an addition sign there. That's our polynomial that we're working with right now. We're dividing it. We're doing the second step, dividing each by the GCF. So 5b divided by b. Anybody know what that is? 5. Yeah, that would be 5. Now, if you can't get that without showing some work, how would the work go for that one? We would show 5b over b, that's dividing. What happens with those b's?
They cancel out.
They cancel out. So we end up with just 5, don't we? Okay. 9b cubed divided by b.
9 squared.
That'd be 9b squared. Yeah. So again, you need to do this over here, and maybe you even need to do that, like this. Maybe you need to just write out all those b's. Nothing to cancel with in that 9, but these b's cancel, and we see that we have 9b squared. If we have a good GCF, there should never be a denominator left. Everything should cancel out of the denominator. So now, what we really have here is, remember there's a plus. 5 plus 9b squared. That's our other factor. This is our other factor. So we have the GCF and we have this. So we are going to say that we have, oh no, I'm writing that wrong. We have our GCF is going to be written first. And our other one gets put in parentheses behind it. Oh, I put a spot for the answer, and then I'm trying to write it off to the side there. This is really where I meant to write it, right here. That's our answer. We have factored the polynomial 5b plus 9b cubed. And remember what I said, we just undid multiplying. So in other words, when it was given to us in the beginning, this was the result of a multiplication problem. This is the multiplication problem before it was done. So if we actually took b times 5, if we did our distributive property here, would we get back to what we started with? What's b times 5? 5b plus, what's b times 9b squared?
9b cubed.
9b cubed. It takes us back to where we started. When you look at this other factor here, you guys, you need to make sure you take time to do this too. If you look at this and you say, is there anything else that would go into 5 that would also go into 9b squared other than 1?
No.
So that's the question. Otherwise you didn't get a good GCF or you didn't divide well. Something went wrong. Okay. Okay, first thing we're going to do with subtraction is we're going to change to add the opposite to help us be more successful. 12x squared plus negative 8x. We're going to show work by saying, first of all, we're going to do what's the GCF of the number parts. I meant for that to be in older. GCF of our number parts are 12 and negative 8. And then we have our variable parts. What's the GCF of x squared and x? Who thinks they can have the GCF of the number parts for us? Stefan?
4 or negative 4.
4 or negative 4. Okay, so which one should we do? Should we do 4?
I did 4, yeah.
Okay. And GCF of x squared and x. What's the GCF of our variable parts? 1? X. So now, remember, we have to take those and multiply them times each other, so it's 4x, isn't it? So that's kind of like our step 1. Let me put that over here. In step 1, you need to find the GCF factor. Okay? You're finding the GCF factor. I think we can skip a line so we can make our notes a little bit easier to read. In step 2, we're going to do our dividing part. So we're going to take the 12x squared, and it has to get divided by our GCF. And then our negative 8x has to get divided by the same thing, the GCF. So 12x squared divided by 4x and negative 8x divided by 4x. So when you're doing that, you say to yourself, what's 12 divided by 4? 3. What's x squared divided by x? X. Okay, again, for those of us who couldn't do that up here, we would just do something like this. We would say we have 12 times x over 4 times x. And maybe that's how we have to look at it. 4 goes into 12 3 times. These x's cancel, and notice we have 3x left. Okay, what's a negative 8x divided by 4x? We say to ourselves, what's negative 8 divided by 4? Negative 2. And then x divided by x. That's 1, right? So they're gone. Okay, remember what's in between here?
Plus
A plus sign. So what does this give us right here? 3x plus negative 2. This is our one that today is going to go in parentheses. So maybe you just want to put it in parentheses right away there so you don't forget that that's what has to happen with it. The result after you divide ends up in parentheses. So now let's put our, that's right what we have here. We're really naming these in their factored form. So it's factored name. What's its factored name? What was the multiplication problem this came from? This answer, 12x squared minus 8x. Trey?
4x and 3x minus 2.
Okay. And cleaned up, we can say it's 3x minus 2, can't we? 4x times in parentheses, 3x minus 2. So there's a couple of different things you could do now to see if you're good at this or not. You could look at 3x and you could look at 2 and say, is there anything other than 1 that divides into 3x and 2?
No.
Is there anything else that can be divided out of 3x and 2 other than 1? No. Okay, the other thing you could do is you could say, okay, now if I did do the multiplication problem, would it go back to what we started with? So what's 4x times 3x?
12x.
That's 12x squared. That's the first term. Minus, what's 4x times 2?
Negative 8.
It's 8x, so minus 8x. So we have a good factored name for our polynomial. Okay, where did we leave you behind? What do you want to ask questions about? Josh? Okay, I think that was a rhetorical question, right? I'm not sure I need to answer that, but I will. Yes, you do. Okay. Notice that what's true about our next polynomial? It's not a binomial, it's a trinomial. Notice on the front side, when we had a binomial that we were factoring into the GCF, the second factor was a what? Was it a binomial? The one in parentheses? The GCF was a monomial. The other factor was a binomial. What do you suppose the other factor is going to be in this one because it's a trinomial to start with? Trinomial factor also. Okay, let's rename this first. Get that subtraction out of there. 8x to the 4th plus 4x cubed plus negative 2x squared. Yes, Ariel. This is where happens when I let my students write copies. Okay, so can you just write it down? Do you have a white space and you can just do it that way? Just you can color this. Okay, so 8x to the 4th plus 4x cubed plus negative 2x squared. Remember in step 1. In step 1 we're finding the GCF. So we're going to say GCF of 8 and 4 and negative 2. The number parts. Okay, what's the largest number that divides out of all three of those? Right?
2.
2. Okay, so our GCF of the number part is 2. Our GCF of the variable part's next. We have x to the 4th, and we have x cubed, and we have x squared. GCF of the variable parts, x to the 4th, x cubed, x squared. What's that GCF?
Just X.
Cameron?
X squared.
X squared. X squared. There are 2 factors of x in x squared. There are 3 factors of x in x cubed. There are 3 factors of x in x to the 4th. The most that you can take out of all 3 of them are 2 factors of x, so x squared. So this becomes a GCF of what?
2x squared.
2x squared. Okay, step 1, find the GCF. Okay, anybody want to ask questions on that before we move on to step 2? Okay, let's try step 2 then. Step 2 says, do the dividing. So we're going to take 8x to the 4th and divide by 2x squared. We have to take the 4x cubed and divide by 2x squared. And we have to take our negative 2x squared and divide by 2x squared. Every time you're dividing by the GCF, take each of the original terms from your polynomial, and each of them has to be divided by that GCF. Okay, you go ahead and divide those out, and let's see what kind of results you get without us talking you through it. What are the results of all those divisions? And then let's put plus signs over here too. Plus, plus, so we don't forget that that was a polynomial to start with. Okay, compare with your table mate, and if you don't have a table mate, nothing you can turn around and compare with Stefan and Juan. Compare answers, see what you, if you agree.
Maybe it's like for one. Yeah, that's amazing.
And then you can look up and see who's right. No, it has to be -1. It has to be. So again, how do we write this now? These are pluses between here. So we're going to have, what's our other factor? 4x squared plus 2x minus plus a -1. And I look at those three terms and I say, you know what, if I did a good job, there's nothing else that divides into 4x squared and 2x and -1 other than 1. Did I do a good job? Is there anything else I can take to divide out of 4x squared, 2x, and -1 other than 1? Okay, so then let's do this again, factored name. So the factored name for our original polynomial in cleaned up fashion is our GCF as our monomial and our trinomial after doing the dividing. How many of you were successful on your own? Way to go. How many of you figured out what you did wrong? And it was just, silly mistake maybe. Anybody need to ask a question before we move on to our last one? This is a really, you guys got to get this down because this isn't the only time you're going to use it, is one time in this lesson. You're going to use it in other types of factoring. You got to be able to GCF like this, doing what we're doing right here. So we got to make sure that we're understanding and mastering this skill. Okay, let's start on the next one then. Step 1. Oh, we can't yet. We haven't changed it to add the opposite. 3x squared plus 4xy plus -2y squared. So we want the GCF of 3 and 4 and -2. What is that?
1.
It's 1. There isn't anything else that goes into all three of those numbers other than 1. So the GCF of the number parts is 1. GCF now are the variable parts. So we have our x squared and our xy and our y squared. X squared and our xy and our y squared.
Used to be XY.
Okay, remember, whatever we decide it is, it has to be able to be divided out of all three of them. So, do all three of them have x's? If then can we have an x in our GCF? Okay. Do all three of them have y's? No. Then can we have a y in our GCF? Okay, so what's the GCF? 1. It's 1 again. Well, the GCF is only 1 for both of them. 1 times 1 is 1. When we divide something by 1, if we were to move on to step 2 right now, and we divided each piece by 1, what would happen? Yeah, it'd be the same. So we're going to say we get to stop here when this happens, and we get to stop. We get to stop and say cannot be factored. Cannot be factored. It's worthless to do it. It's silly to write 1 and then put the polynomial in parentheses right next to it. Because multiplying by 1 doesn't get us anywhere. Keeps it the same. So cannot be factored. But we have to have that much to prove it. At least you got to show that the GCF of the number part was 1, the GCF of the variable part was 1, and then you get to say cannot be factored. You don't get to take that cop out though, and when you don't want to think, to just say the GCF is 1, the GCF of 1 is 1, cannot be factored. That's not going to help you later on down the road. Trey?
If we can't get to the problem that came from, then what was there a problem that came from?
You mean if you can't factor it?
Yeah.
Then there was never a multiplication problem. There wasn't a multiplication problem that the GCF can get it to, okay? So we're going to say this was just a polynomial that didn't come from a multiplication problem at this point. Anybody else? Any other concerns? Okay, then let's get going on homework.